Okay, so we're factoring the trinomial here. We're multiplying to 6 times 12, our A times our C. A in this case is 6. Our C is 12. So we're doing 6 times 12, and we're adding to 17. So 6 times 12 is 72. And B in this case is 17. They're both positives, so that makes it, we know that both our factors when we're multiplying are going to be positive. Okay? So I got this one right. I mean, I didn't have to go through any sort of steps or anything. I just did the one fact that I know multiplies to 72. It just came to my head, and it was 9 times 8. And I checked to see if that added up to 17, and certainly enough it did. So I guess I got lucky on this one. Then I'm going to take that 9 and 8, and I'm going to split the middle term with it. So this 17x becomes 9x, well, positive 9x, and positive 8x. 9 and 8 is 17. And that's what we mean by splitting the middle term. Then I take those two middle terms and I look for common factors. And in this case, I've got a 3x. I'm left with an x, 2x, excuse me, 2x plus 3. And here I've got a 4 that is in common, and I'm left with a 2x plus 3. Simply stated, it's 3x plus 4 times 2x plus 3. Okay. Are there any questions with that? Let's move on to our next problem. And we're going to factor the trinomial. However, this time, let's solve. Let's solve. Let's take it to the next step and let's solve this trinomial. Okay? So get started. Okay, let's check it out. When we multiply here, we're multiplying to what? Lucas, what are we multiplying to? To 40s. It's actually, we're multiplying to negative 240. And that actually changes it just a second. And it adds to negative 2. Okay, so we have to find a positive and a negative that multiplies to 240 but adds to negative 2. I actually don't think this changes it too much. Okay. Oh, it does. It does. So let's go ahead and take a moment and let's see if we can find two factors that multiply to negative 240 but add to negative 2. Did anyone find two factors that multiply to negative 240 and add to negative 2? No. I actually, as Noah said, I started writing out all the multiplication facts. I even used my calculator on this just to make sure. And yeah, there's nothing that multiplies to negative 240 and adds to negative 2. So this is relatively prime, and we can't. At this point, we can't solve it until we learn something a little more. But yeah, for right now, this is not factorable. Okay. All right, we've got two more here. Let's go ahead. Let's do this. Let's take this half of the class. You're going to work on this one. This half of the class, you're going to work on this one. If you finish early, feel free to work on the other one. Okay, so if you're solving this at home, you can hit pause. Otherwise, we're going to have a student volunteer.
It's frozen.
We're going to have a student volunteer come up here and solve this. So, Olivia, take it away. please talk through as you work.
Okay, so you are multiplying by 40. 40. And then you're adding by negative 14. So for that, it is negative 10 times times negative 4. And then negative 10 plus negative 4. So that turns into this.
That's fine. We can move the problem.
Okay, so that is that. And then
I like how you kept the equals 0 up there to remind you along the way that you're actually solving this. So not just factoring, but also solving.
And then I just took those two right there. So there's 5 that goes into that. So 5x. And then x minus 2. Like that. And there's a negative 4, yeah. And then x plus 2, yeah.
I think that's minus 2 there because you you divided positive 8 by negative 4.
Okay. And then do this. Like that. Oh, I should do that. Okay. Work equals 0, and then x minus 2 equals 0, plus 2, x equals 0, or 2, I mean, and then and then 5.
You want some more room?
Yeah.
Here you go.
X equals 4/5. So basically, like that.
Excellent. Good work.
Thank you.
Okay, so and the one thing I noticed on that, I like how Olivia, she didn't write it out 5x minus 4 times x minus 2. She actually just went to solving for 0 at that point. And that's totally fine. I usually write it out, but she started to, but then changed her mind, so it doesn't matter. Okay, someone from this side that would like to solve this problem. Not everyone at once. Is this one harder? What if someone can get it to factoring and you don't know how to solve for 0, I'd be glad to help you with that. Okay.
Well, I did it, but I'm not doing it.
Nice. Okay, since we don't have any volunteers, I'm going to go ahead and work this through with you. So what am I multiplying to? Sarah?
Negative 21 and 8, which is 168.
Negative 168. So I'm multiplying to negative 168, and I'm adding to 2. So I know right now, 1 is going to be positive and 1 is going to be negative. I also know another thing. These two factors are going to be relatively close to each other. Okay, they're going to be relatively close to each other. So what two factors multiply to negative 168 and add to 2? Austin. So 12 times 14 is 168.
Yeah, and they add.
So if I've got negative 12 and 14, so and negative 12 plus 14 equals 2. Okay. So once I have those, then I want to ensure that you know what to do next. Austin, what do I do next? Because you showed me these two numbers. I just didn't go anywhere else. You didn't write anything else out. Okay, so tell me what to write down.
It'd be, okay, 8. So you have ax to the second
Okay,
minus 12x.
good.
Yes. And then you have plus 14 minus 21.
14x, right?
Yeah, minus 21.
Minus 21,
Equals 0.
and put that equals 0 so it reminds you that we're actually solving this problem. Okay, so now I'm going to take those two binomials and I'm going to factor out. I'm going to factor out a common term. So here I'm going to factor out a 4x. So if I factor out a 4x, I'm left with 2x plus 3. Minus 3, thank you. It's important that we get those right too. It's easy to make that mistake. I can vouch for that. And here I'm going to factor out a 7. And I'm left with 2x minus 3. So I'm going to just use, I'm going to go here, I'm going to say 4x. Try to keep this problem here. 4x plus 7 times 2x minus 3 equals 0. So now that I have that factored form, now I can solve. I can't solve until I factor it out like that. It's going to be too hard to find your answer. Not impossible, but it's going to be pretty tricky to find this without that. But I know that I have to set this equal to 0, and I have to set this binomial equal to 0. Because if either of those binomials equals 0, then the whole thing is going to equal 0. Because when you multiply by 0, it equals 0. You should start to be getting to, these should become a little easier for you to almost do in your head. And then we have x equals negative 7/4. So I just divide both sides by 4. Then this one is going to be 3/2. I can already see it. I'm going to add 3 to both sides of the equation. 2x equals 3. So we divide by 2. X equals 3/2. So my solution set in this case is negative 7/4 and 3/2. And don't worry, because they may end up coming as fractions, especially when we're solving these. Yes, sir.
Can those be written as mixed numbers too, or do they have to be in couple?
Yeah, if you wrote them as mixed numbers, that'd be fine. I guess I would prefer that you write them like this for an answer's sake, for grading's sake. But that'll maybe I should make them do mixed numbers, but just write it like that for now. If you write as a mixed number, I'm not going to mark it wrong. That's certainly not incorrect. Yes,
If you
ma'am.
write them as mixed numbers on Khan, it doesn't accept it. It says it's wrong.
Does it?
Yeah, no matter what.
That's frustrating. I would report that to Con.
Yeah, I did. And it's like, it's still not fun.
Yeah, well, it's not necessarily going to come right away on Con, but yeah, I would report it to them and just say this should be correct. Theoretically, it is. Okay, moving on. Today, our new concept is the difference of two perfect squares. And when we talk about a perfect square, we're talking about numbers that, if you multiply it by itself, it equals that. So, give me an example of a perfect square. Yes, sir.
49.
49. Good. How about some other perfect squares? Jasmine. 64. 25.
36.
36.
4.
4. 1. Good. 9. What's that? 144. Can someone give me a variable that's a perfect square?
X to the second.
X to the second power. Good. Y to the second. Sure. Y to the fourth. Yeah. You're getting the drift there. Okay. So the difference of two squares is you're looking for numbers that have two perfect squares. And for example, if I am given n squared minus 25. I just have to ask myself, do I have two perfect squares here? Do I have two perfect squares? Is n squared a perfect square?
Yeah.
Is -5 or -25 a perfect square?
Yeah.
Excuse me, I shouldn't say it's -25. Is 25 a perfect square?
Yeah.
Okay, sorry about that. So, and the reason, so I got two squares, and it's the difference of two squares. Okay, it's the difference, so we have to be subtracting. And if we have the difference of two squares, it's going to be a plus b times a minus b, where a is the square root of. So a is the square root of this term. Okay, so a equals the square root of a, and b equals the square root of b. So in this case, what's the square root of n squared? N. Perfect. So we've got n plus, what's the square root of 25? 5. N plus 5 times n minus 5. That is this factor. Now let me show you why. If we do n times n, that's n squared. And then n times -5, that's -5n. 5 times positive n, and that's positive 5n. 5 times -5, it's -25. So you can see our middle terms here cancel each other out. -5n plus n. We're left with n squared minus 25. And that's why this works all the time, because these middle terms end up canceling each other out. When we split the middle term, it cancels them out. Okay? So we're looking for work. In this case, we are multiplying. If we wanted to, we could use the same term. We're multiplying to -25, but adding to 0, because there's no b. It's the same process of the difference of two squares, but it's a lot easier once you learn a plus b times a minus b. Okay? So let's take a look at another one. Oh, these are the good ones. Problem like, and these are examples that are in your book, but I'll give you a few others that we can practice also. So if we're given 48 a to the third minus 12a. If you look at this problem, can this be factored? Can this be factored? What can I factor here? Ben?
12A.
12a. Okay? They have a 12a in common. So I'm going to take that 12a out, and what am I left with? Olivia?
4.
For what?
A.
4a to the second
Oh,
minus
Oh,
what's 12a minus, or divided by, yeah, minus 1. Yep. You're just dividing. What's 12a divided by 12a? So now we look at this. And once you're done factoring, always look, always look to see, are you completely done? Is there anything else you can factor? And one of the questions you ask yourself is, do you have the difference of two perfect squares? In this case, do I have the difference of two perfect squares? Is 4 a perfect square?
yes.
Yes. Is a squared a perfect square?
Yes.
Is -1, or excuse me, is 1 a perfect square?
Yes.
Yeah. Okay, so remember, we've got a here is 4a squared. B here is this. So what is the square root of 4a squared?
2A.
2a. You got it. And what is the square root of b?
1.
Okay, 1. So remember, it follows the form of a plus b times a minus b. So what's my answer going to be? If it follows the form a plus b times a minus b, and a is 2a, and b is 1. Okay, Jacob?
It'd be 2a plus 1.
2a plus 1,
And then it'd be 2a minus 1.
2a minus 1.
Wait, how do you go from 4a to 2a?
Square.
That a is also is the square root of a. So if a is 4a squared, the square root of 4a squared, the square root of 4 is 2, the square root of a squared is a. Okay, so our answer then, we can't forget about this, is 12a times 2a squared plus 1 times 2a, not 2a squared, 2a plus 1 times 2a minus 1. Austin?
Are we gonna do these with trinomials?
You could get this as a trinomial as you factor something.
Okay.
If you factor
I mean,
something,
like, are we gonna work with trinomials with this, with all the different squares?
no, well, this is a, I mean, and
So I thought she factored on that.
sure. Okay.
Something like
Okay, what was your question again, Austin?
Are we gonna work with trinomials with this?
So, I mean, here I've got a polynomial that's greater than a trinomial. So yes, you can use, we can end up using this for a trinomial. However, what I would say is that our trinomial is going to be bigger, it's going to have a very, an exponent that is larger than just to the second power.
Okay. I was just wondering.
So, okay, anyway, we're going to get to this problem in just a little bit. So recapping real quick. Okay, we know that if we have the difference of two perfect squares, we can use the form of a white on white is not going to work in that case. We can use the form of a plus b times a minus b, where a is the square root of a, and b is the square root of b. So in this case, in this problem, using that logic over here, a is m squared, and b is 64. Do we have the difference of two perfect squares? Is a perfect square here?
Yes.
Yes, because m to the second power is a perfect square. It's like m times m. We don't know what m is, but m times m is a square, is a perfect square. What about negative 64? Excuse me, how about 64? I would say negative 64, but
Yes, you do.
yeah. 8 times 8 fell on the floor when he got it done. He was playing Nintendo 64.
No.
Oh! I did it.
Okay, so anyway, so go ahead and can someone tell me what the answer would be here? Brendan,
10 and 8. Oh, sorry.
factor it out.
Okay, I'm sorry.
Sam?
Parentheses m plus 8 times m minus 8.
M plus 8 times m minus 8. So once you have a and b, you just put it in the form a plus b times a minus b. Remember. It's the same thing as you're multiplying to a times c and adding to b. Well, in this case, a is, it's a little different. A is 1 and b is 64. It's actually negative 64. So what adds to negative 64, but I just confused you completely. You have to think of a and b as a little different here. I could call this a plus c times a, that's probably a better way to teach this, times a minus c. That way you know that c then, c is always the last term. This is a, this is c. So we're multiplying to a times c, and adding to b. A times c is negative 64, because it's 1 times that. And then b, in this case, is 0. B is 0. You can even split the middle term with that if you wanted to. Yes?
How would A and C equal the square root of themselves if they're a specific number?
Well, if this way, you would have to think of c as just being 64. I know what you're saying, but I just want to show you that if you really had to and you couldn't remember a plus c times a minus c or a plus b times a minus b, your book's going to say a plus b times a minus b, or they're saying. But when you realize this can be factored the same way, you can work through it like this. You figure out what multiplies to negative 64 and adds 0. In this case, it's 8 times negative 8. And you end up getting, and since the leading coefficient is 1, you can just write it out like this. Or you could do m squared plus 8m minus 8m minus 64. And you can split the middle term here, factor out an m, and you're left with m plus 8. And you factor out negative 8, and you're left with m plus 8. So you got m minus 8 times m plus 8. It follows the same process. Or you just know that 8 times 8, and since the leading coefficient is 1, you can write it like that, m plus 8 times m minus 8. Or if you just remember, if I have the difference of two perfect squares, I can just put it in terms like that. But it follows the same process. And that's what's cool about algebra, at least I like it. It's what makes sense for me, is that it follows the same process. No matter if it has this special circumstance or not, it still follows the process. All I'm teaching you today is a shortcut. That's all I'm really doing, is trying to get you to realize that you can take a shortcut by factoring the difference of two perfect squares. Tests love these questions. Tests are always trying to get you to recognize the difference of two perfect squares. You think it's hard, you say, oh, I can't factor it, but you can because there's the difference of two perfect squares. They love to test you with this. I know I'll have a few examples like that, but I know on like standardized testing, on your SAT or ACT test when you're going into college, this is the type of question that they'll ask. And you'll factor everything out, and then it'll still have this little perfect square in there, and you didn't factor that out and you missed an answer. They love to trick you like that. Anyway, moving right along. Here's another problem. Okay, ask yourself, is this the difference of two perfect squares? If it is, write down an answer.
Yeah.
This is where I would definitely wouldn't want to multiply to 81 times 16, right? That's going to be, and add to 0. That's going to be a pain in the butt trying to add to 80 or multiply to 81 times 16 and then adding to 0. Just not going to be fun. So this is where you'd want to use the shortcut. This one you might be able to do in your head as you go along, but if you're not quite there, let's look at it. What's A in this case? What is A? Olivia?
16y squared.
Good, 16y squared. And what we can either call B or C. I don't know what you want to do. The book calls it B, but in this case, well, what is B? What is B? Yeah.
81z squared.
81z squared. So A is 16y squared, and B is 81z squared. And then we have to take the square roots of those. What's the square root of 16? What's the square root of 16y squared? Lucas?
4y.
4y, good. 4y times 4y is 16y squared. And what's the square root of 81z squared? Jasmine? 9z. So, following what we just learned, it's a plus b times a minus b. And I'm just using, in this case, I'm using b because I know the book is going to use those terms. So, if you really want to call it c, that's fine too. But in this case, we have a plus b. In this case, a plus b. B over here is 9z. and then we do a minus b, or y minus 19. Simple as that. Yes, sir.
Is it okay if we like switch the signs? Things like instead of having 4y plus 9z, we have 4y minus 9z? Or won't that work?
One has to be positive. Are you saying
Because-
can you write it like this?
Yeah, I think, yeah, that's what I was saying.
Okay, I'm going to go back to the beginning of the year. Can you do does A times B equal B times A?
Yeah.
Does 3 times 2 equal 2 times 3? So all you did was,
Okay, so
it's just a, I don't know if you want to call it a turnaround fact or just a, it's a fact family. Okay, moving on. This was one where, first off, do I have the difference of 2 perfect squares?
no.
So always start by asking yourself, do I have the difference of 2 perfect squares?
No.
Okay, 3 is not a perfect square, right? So can I factor anything out of this? Zach, is there something that I can factor out of this binomial? Okay, Nathan?
3b.
3b. Okay, we can factor out a 3b in this binomial. We're left with what? Nathan, go ahead and finish. What are we left with here?
B squared.
B squared minus 9. Okay, and then when you think you're done, you're going to ask yourself one more question. Can I factor anything else? Can I factor anything else out of this side? Well,
Yeah.
3b. What?
Oh, wait, never mind.
I can factor out 1.
I mean, the other one.
Can I factor anything out of this part?
Yes.
And when you do this, you ask yourself again, is this the difference of 2 perfect squares? Is this the difference of 2 perfect squares? Absolutely. Is b squared, Riley? Is b squared, is that a perfect square? Is 9 a perfect square? Okay, so now we've got 3b times square root of a, well, square root of b squared is, Riley, b. And then the square root of 9 is 3. So we have b plus 3 times b minus 3. Okay? So, and then if I multiplied this all out, if I multiplied 3b times b plus 3, and then multiplied it times that, I would get 3b cubed minus 27b. Okay? And it's just working in opposite order. Okay, next. So I ask myself, what's the first question I ask myself? Looking at factoring this, what do I want to ask myself? Jasmine? Is this the difference of 2 perfect squares? Is 2x to the 4th a perfect square?
Yes.
No, yeah. No.
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 Yeah.
2 is not a perfect square. 2 is not a perfect square. So what's the next thing I ask myself? Anyone?
Well, 62
Jacob?
you factor anything out.
Can you factor anything out of these numbers? Can you? Samantha, you're shaking your head. What can I factor out of here? A 2. So if I factor out a 2 here, I'm left with x to the 4th minus 81. Do I have 2 perfect squares? Or do I have 2 perfect squares? Do I have a perfect square now?
Yes.
Is that a perfect square?
Yes.
Absolutely. So now we're going to do 2 times x. What's the square root of x squared?
X to the
Q. No, X squared.
X squared. X squared minus
9.
9, and x squared
Plus.
plus 9. Now I ask myself what question?
Is this factored out?
Is this totally factored out?
Yes.
Is the 2 factored?
Yeah.
Yes, that's as factored as you get. Is x squared minus 9?
No.
Ah, see where these get tricky. This is a perfect square. Okay? So this is going to be 2 times x plus 3, x minus 3, times x squared plus 9. That's big, isn't it?
Don't we have to do that again?
We have to ask ourselves, is everything factored? Is this factored?
Yes.
Can I factor anything out of here?
No.
Can I factor anything out of here?
No.
Can I factor anything out of here?
Yes.
Why?
Square.
Wait.
Why can I factor something out of here? Ben,
Because x and 9 are perfect squares.
is it the difference of 2 perfect squares?
No.
No, it's not the difference. This is the sum of 2 perfect squares. That is, you can't factor that. Okay? There's nothing else you can factor. It only applies to the difference of 2 perfect squares. You have to see a subtraction sign there. Olivia?
Oh. So, wait, explain why then x squared wait, which one is the answer?
This is your final answer.
Why is there an extra parentheses on the end like the x squared plus 9?
Because when I factored this, when I did x plus 3 times x minus 3, that was just for this binomial. Because that was the difference of 2 perfect squares. X squared is a perfect square, and 9 is a perfect square. This one we can't factor this out because it's not the difference of 2 perfect squares.
Okay.
So this x plus 3, x minus 3 is the same thing as x squared minus 9. It's just in factored form.
And the 2 is still on there
Because we factored that out at the very beginning of the problem. Probably makes sense if I wrote it up here. At the very beginning of the problem, we couldn't do anything until we factored out that 2.
Okay. Alright, thank you.
You're welcome. So yeah, it's just kind of working backwards there. This is the final answer, and you can see what I did each time. This one comes from right here. Okay, this here comes from that, and this 2 comes from that. The fact that there was a 2, there's a greatest common factor of 2 at the very beginning of the problem. But you can't do any of it until you factored that 2 out. If you didn't factor that 2 out, you would just miss. Well, obviously, you miss all the steps. But okay, just a couple more examples. Let's look at this. 4y to the 4th minus 2500. This one's very. I'm going to skip this one for now. Special case circumstance. If I looked at this, how would you go about attacking this problem? Just looking at it to begin with. Austin?
I'm just taking a random guess at this. And you combine the 5x to get 5x to the 3rd. And I'm not sure.
Okay. Jacob?
What I would do is that I would switch the 15x squared and the negative 5x, and I'd put them to the other sides. So then after that, you could kind of factor them out and find out the greatest common factor out of both of the common areas. And then when you
So you're saying switch them like that?
yeah,
You wouldn't have to, though.
no, I wouldn't have to. But
I mean, you could have looked for what was common in this
Yeah.
and what's common in that. That would have been fine too. So you're grouping, you're factoring by grouping, okay?
And
So
then that you get the greatest common factor out of the first two numbers and then the last two numbers.
okay, so in this case I got 5x, so I'm left with x
Squared minus 1.
x squared minus 1, and then
And then pull up the 15. So,
15, I'm left with x squared minus 1.
and then you would actually group them together as 5x plus 15. And then that you would have x squared minus 1.
And then what do we have to ask ourselves?
Is this
Is everything completely factored? Is 5x plus 15 completely factored? Right, I see you shaking your head there. What can I factor out of this? A 5.
we can't
Good.
do that because it's a plus.
A 5. It's not a difference of two perfect squares, but you can factor out a 5. So it's x plus 3. Is x squared minus 1 factored?
No.
Why? Lucas? Is that factored? X squared minus 1? No. Do you have the difference of two perfect squares? Yeah, you have the difference, meaning that we're subtracting here, of two perfect squares. Well, x squared is a perfect square, 1 is a perfect square. So we have x plus 1 times x minus 1. A plus b times a minus b. That's the answer. So we go through all those steps just to get to right there. Okay? We can do the same thing here. I'm going to skip that, and I just want to show you one more type of problem. 48y 48y to the third equals 3y. If you look at this problem, what can you do? What are you going to do to solve this problem? Jasmine? You're going to divide each side by 3y?
I thought that too.
Not quite. You could. You could divide each side, but you'd have it equaling 1. Samantha?
Maybe subtract from both sides.
Yeah, let's subtract 3y. And whenever it says solve, with the key, and I didn't write this up here, but anytime you see solve with these, make it equal to 0. Okay? You're going to solve for y, but you need to make it equal to 0. So in this case, you've got 48y to the third equals, minus 3y equals 0. So I have to subtract 3y from both sides of the equation. Now I can solve the problem. But before I can solve it, I have to ask myself, is this factored? Is it a difference of two perfect squares? Is that the difference of two perfect squares? Yes or no? I see you shaking. I'm going to say no here. Can we factor anything out of 48 and 3? 48y to the third and 3y. Yes, sir. 3y. 3y. We can factor out a 3y. So if I factor out 3y here, I've got 3y times, what's 16? 16y squared minus 1 equals 0. Are we done here? Can I factor anything out of here? He doesn't have time to be distracted. I don't know if you do either. 16y squared minus 1. Is this factor? That?
No, because of it, there's a difference of perfect squares.
We do have a difference of two perfect squares. So that's going to be 3y times, and tell me what that's going to equal here, Ben.
4y plus 1 and 4y minus 1.
Good. 4y plus 1 times 4y minus 1 equals 0. How many answers am I going to have here?
3.
Thank you. Why are we going to have 3 answers?
Because there's like 3 separate things that have to equal 0.
3 separate things that could equal 0. 3 different terms. There's a monomial and 2 binomials. So 3y equals 0, 4y plus 1 equals 0, and 4y minus 1 equals 0. If any of those equals 0, the whole thing is going to equal 0. So this one, y is going to equal 0. 3 times what equals 0? Well, y equals 0. This is going to equal positive 1/4, and I'll show you, negative 1/4. I'm going to subtract 1 from both sides of the equation. So I've got 4y equals negative 1. Divide by 4. Y equals negative 1/4. And this one's just going to equal positive 1/4 because I add 1. It's the same thing. I've got 4y equals 1, so y equals 1/4. Okay? I know there's a lot in that lesson today. There's a lot with the difference of 2 perfect squares. Start by asking yourself, when you see a binomial, is it a perfect square? Do you have the difference of 2 perfect squares? If you do, great. Go ahead and factor. If you don't, then you ask yourself, what's the greatest common factor? If you have a greatest common factor, you factor. Are you done? Always ask yourself at the end of the question, is there a difference of 2 perfect squares? Can I find another greatest common factor? And sometimes it can. Sometimes you can do this process 2 or 3 times until you say no, no, no. That, I guarantee, you will be tricked with on your quiz, or on your test, which is on Friday.
What test? Oh, this chapter test?
Chapter test, yes. So I'm going to give you the last 15 minutes to work on your homework, which is somewhere around here. It is?
Yeah.
Oh, man. What I would say that you're close to being able to do is this right here. You should be able to work on page 505. Sir.
This is cool pictures.
Oh, yeah.